this appears to be a problem where trying to calculate x directly would present some difficulties. Maybe not. I'm going to take advantage of I guess we'll call it a symmetric approach. Notice that 996 is halfway between 1007 and 985. It's just the average. You can sum up those two numbers. That's the average. So you can do, it's the middle. So you can add 11 to 996. And then you can subtract 11 from 996. Okay. Now you'll see in a minute, you may already see why this is a good approach. And again, if you think you can do it directly, go ahead and just try to use the difference of two cubes result. This way seems to be better. Let's see how it works. I decided to go ahead and just do it in general. This special case here that's for this specific problem certainly is in this form. Now notice the cubic terms cancel. Okay, the k cubed here will cancel with the k cubed here, so that's one term that gets wiped out. And also these two series are exactly the same terms, except two of these terms are negative, or the negatives of the respective two terms. I think the second and third terms. Is it the second? Yeah, the second. There's four terms in the series, so the second and third terms, I believe, cancel. Okay, so I think two of them cancel, I believe. Okay, but anyway, notice that what's going on here is the binomial coefficients, 3, 1, 3 choose 1 equals 3 choose 2. Is equal to 3 is important here. In this part right here, right, the k squared term would last, right? And then I think there's four terms. 2 cancel? 2 or 3 cancel? I think so. 2 of the terms cancel, I believe. Okay. So, yeah, the k cubed term, right. The k cubed term cancels, and then the second term in this series would be negative, canceling with the positive version over here, is how that works, I believe. Okay, and so we end up with this. Now, notice that this looks a little strange. You can see where the 3 comes from, but the 22 times 121 is the same thing as 2 times 11 cubed, right, folks? Because, of course, 121 is 11 squared, and then also you have 2 times 11, so you have 2 times 11 cubed. Okay, and again, you have 2 positive 11 cubed terms here. 11 cubed right here, then 11 cubed right here. This minus sign would offset the minus sign over here. Okay, so this all makes quite a bit of sense that we can express x like this. Okay, so let's move along. And you see it's fairly straightforward at this point. You just strip everything away. You divide through by 22 first and subtract 121. And you almost get the radicand up here. You see this radicand is now, it exists. And its form is a very pleasant form as far as the nature of the problem goes. If you take the square root of both sides right here, you end up getting the square root of x over 22 minus 121 equals 2k square root of 3. So you see, this is the general case. Now for our particular problem, what do we have? We had k is equal to 96 here. So our answer to this problem would be 996 996 times the square root of 3 is what how that's intended to read. Yeah, that's 996, kind of a retarded looking version of 9 right there. That's making me feel so guilty. I'll clean that up. There's a better looking 9 right there, folks. So the answer is 996 root 3. And so the main objective here was just to understand that you have an alternating series here where 2 of the terms will cancel with 2 of these positive terms, leaving 2 of them that factor and isolate like this is what's going on there. And then it makes it easy to algebraically isolate x and then take the square root. So to me, it's very, very direct and simpler. But of course, one might be tempted to just try to write this as the difference of 2 cubes. I'm not sure how that would work out. Let me know. It should end up with something like this. But the symmetry here really was a good choice, I think, in terms of the amount of cancellations that occurred. It really simplified the algebra, in my opinion. So that's it, folks. Here's our answer, 996 root 3.